This is Robert Leduc, and in this video I'm going to review challenge activity 3.13.1, which deals with identifying types of function implicants. For me, I think this section was a bit challenging because I had some trouble really understanding the difference between implicants, prime implicants, and essential prime implicants. But this challenge activity did help me to better understand not only these concepts, but was just really good practice for identifying each of these implicant types using a Carnot map. So we'll go ahead and get started, and question number 1 here tells us to enter all of the implicants for the given K-map here, and just want to point out over on the right, I've taken a snip so that we can sort of illustrate how we're working through the problem while we do each one. So the first thing we should probably do is define what an implicant is. And basically, an implicant is a term that covers only the min terms in a function's onset. And another way of saying that is if we refer to the K-map, these are all the boxes, and each box is a min term, that contain a 1. It has to cover all of these 1s here, right? So an implicant is all the ways we can cover these 1s. So in this case, there are 2 main ways we could do it. We can cover or refer to the 1s here separately. Whoops. And these min terms would themselves be implicants of the function. So I will include them first. The first one here is going to be A prime, B prime, C. And the second one is going to be A prime, B, C. But just circling the min terms by themselves isn't the only way we can cover them. The other implicants would also include any simplified term that covers one or more of these min terms. So to illustrate that, on the K-map, we can draw a circle that includes these 2 adjacent cells. And this circle would refer to the term A prime C. So each one of these circles, the individual circles, circling the ones at each min term, as well as the simplified term A prime C, would all be considered implicants for this function. And if we check it, it tells us that we are in fact correct. So there's definitely a lot of overlap because you have to cover essentially every possible circle you can draw to cover all of the min terms where the function is 1. So in the next question, it basically asks us to do the same thing, enter all the implicants for the K-map. So what I'll do is we'll go ahead and get a fresh snip here, and we'll basically do the same steps. Now, one thing I noticed right away is for this function, we have no min terms that are adjacent to each other. So from what I can see, the only implicants we have are the individual minterms themselves. So if I circle all of the minterms that define when the function equals 1, I see there is no way to draw larger circles to cover multiple minterms at a time, since I can't skip over cells and I can't circle cells that are diagonal from each other. So in this case, the implicants for the K-map are simply just the minterms themselves. We don't have any simplified terms that we can include in the set of implicants here. So we'll just list these out. So we have A prime, B prime, C prime. We also have A prime, B, C. And finally, our last minterm is A, B, C prime. And if we enter those, it tells us we have the right answer. So again, implicants are the same as the minterms in this particular example. So for the next question, it tells us to enter the prime implicants for the given K-map. And when we're talking about prime implicants, we have a slightly different definition in that the prime implicant of a function is an implicant that can't have a literal removed without becoming a non-implicant. And so another way to think about that is it is on a K-map the largest possible valid circle that covers a minterm would be a prime implicant. So let's go ahead and get another snip here and zoom in a little bit. And we can see there are a number of prime implicants here. And one thing I notice is there are pretty much all circles larger than 1 that I can use to cover all of these. So let's go ahead and just start with these two that I can wrap around circle on the edges. So these two minterms can be combined into this one prime implicant. And again, I know that it's a prime implicant because it's the largest possible valid circle. I cannot cover these minterms by creating a larger circle because I don't have valid larger circles. I have zeros in there. So that's not going to work. So only this 2-box circle is going to work. Also, I have this set of 1s over here I can circle. Again, there isn't another larger circle I could do because it wouldn't be valid. So that 2-box circle is the biggest I can do. But I have to circle all possible prime implicants. So I also have to include, and I'll write it in another color, this simplified term right here that includes these two minterms. There is obviously overlap between the two circles, but that's okay because it's also a valid prime implicant in that it's the largest circle I can use to cover both of these two minterms. So let's go ahead and enter the terms that I circled here. So the first one, we will denote this as A prime, C prime. And the second one is going to be A prime, B prime. Actually, if we're going in alphabetical order, I should probably put that in first. A prime B prime, then A prime C prime. And then this last circle here can be represented by B prime C. All right, and we'll go ahead and check our answer, and that is what the answer that I'd expected. So we have these three circles are the largest valid circles that we could draw on this Carnot map. So we'll go ahead and skip on to the last problem in this challenge activity. And this time it's asking us to identify the essential prime implicants for this given K-map. And here we're tasked with dealing with a slightly different type of implicant, the essential prime implicant, which is the only prime implicant that will cover a particular minterm in a function's onset. So let's go ahead and do a new snip. And we'll see if we can find the essential prime implicants. Now, the way I would go about identifying these is I would look for minterms in which there is only one largest valid circle that I can use to include it. So I see, for example, there is this one here in the corner, in the A prime, B prime, C prime corner. It is kind of out on its own. There aren't largest overlapping circles for this one. But there is a larger circle than just this one. I can do a wraparound circle that comes over to this side. And this would be the largest valid circle that covers this particular minterm. There is no other largest circle that would cover this. Another one that I see kind of on its own is this one right here. The largest valid circle that would include this is actually a 2-box circle right here. There is no other largest circle that would include that one. That's not valid, and that's not valid. So I only have the one largest valid circle for this minterm right here. Now, there is an additional prime implicant here. We have this, and we have another prime implicant right over here. These are all largest circles that cover these two minterms. However, these are not essential prime implicants. The reason they're not essential is because they are not the only largest circles that will cover these. The essential prime implicants should be the only largest circles for a particular minterm. So I will not include these. Now, if we were going to go ahead and finish writing the function that would include all of the valid terms for this function, I would have to include all of the minterms, right? So what I would have to do is I would have to pick one of these simplified terms. Either would be valid to cover this particular one, but either way, neither is an essential prime implicant. So for the context of this problem, I'm not going to include that. So let's get rid of these, and we'll simplify this down to only the essential prime implicants, which would be A, C, which is this one right here, and then we have A prime, C prime. Right. And that's it. Those are the only two essential prime implicants for this K-map. And when we check it, it tells us we got the right answer.